Good morning. Welcome to NASA's Kennedy Space Center. We're a day before launch of the orbital ATK Cygnus going to the International Space Station carrying cargo. We're going to do a little bit of a deep dive today into it in order to explore what's on board, how we're launching it, what the launch tomorrow afternoon is looking forward to, and also some of the other items that are going on the International Space Station. For those of you who are joining us online, we invite you to follow along on the conversation during today's NASA Social using the hashtag NASASocial. You can also follow along on @NASA during live launch coverage tomorrow, and you can follow @NASASocial to follow along with the entire event, as we'll be highlighting some of the best social media posts from our social media followers who are here in the audience with us. Tomorrow night for launch coverage, you can follow along using the hashtag Cygnus. And you can also follow our partners who are launching @ULA Launch and @Orbital ATK. During today's briefing, if you have a question that you'd like to ask of anyone here on the panel, please ask it using the hashtag AskNASA. Without further ado, though, we'll jump right into it, and we'll get started with a briefing from the weather officer from the 45th Weather Squadron of the United States Air Force, Todd McNamara.
Good morning, everyone. The weather is kind of a good news, bad news, good news story. So starting off with the good news, we've had high pressure over the top of us for the last several days. We've had rain showers moving through that easterly flow pattern with a high pressure up to our north. So maybe a scattered shower here or there the last few days. Overall, great conditions. The bad news is kind of coming, though. At this time, the high pressure is starting to retreat. It's going to retreat throughout the day. And we got a frontal boundary that's extending from the Ohio Valley region. In fact, if we take a look at the satellite, we can bring it up and kind of take a look at it. It looks pretty ominous. You can see that frontal boundary and all the clouds associated with it extending from the Ohio Valley region down through Texas. All the yellows and reds are all the real high clouds and a lot of thunderstorms and heavy rain showers that are associated with that system. So you can see those showers and thunderstorms kind of extending down through the Louisiana area, and right now Louisiana has quite a few thunderstorms and rain showers going on. As far as Florida, we're still underneath that high pressure system. Brief shower in Cocoa Beach this morning, but overall we're under high pressure yet and still pretty decent conditions, just some scattered clouds out there. As the day wears on, that high pressure system is going to retreat. The frontal boundary is going to move through our area, and we're expecting that to move through us sometime around the mornings when the surface front will actually move through. So the surface front comes through here early morning, Thursday morning, somewhere around the 4 o'clock in the morning time frame. As it does, we're going to transition from this high pressure, nice conditions to more cloudy skies and some rain showers. The good news, part of the good news story, is that during roll this morning, we're looking at favorable conditions. So the winds are going to be out of the south, rather light, and we're not expecting any shower activity or thunderstorm activity for the roll over the next couple hours. So that's not going to affect the roll whatsoever. But somewhere around the 3 o'clock time frame, we'll start to see those showers work their way in. Maybe an isolated thunderstorm. I think most of the thunderstorms are going to be kind of up to the north, and they're going to be late in the day. So I think we're going to kind of stay away from the thunderstorm activity, but we will have some showers move through the area. I think around 2 o'clock, 3 o'clock in the morning, we'll start to see it clear up. So that's kind of the bad news part of the story. Back to a good news part. Tomorrow is going to look favorable. The front will move to the south of the launch area. We're expecting it somewhere around the Lake Okeechobee region, somewhere in there. And we're just going to be dealing with some residual moisture. The upper level part of the system will still be off to our west, and that's kind of what's keeping it from a really, really good story. That upper level trough out to the west and the front down to our south, we'll have some clouds in the area. So we're looking at scattered clouds in the low levels, some broken clouds in the mid levels, and some broken conditions in the upper levels. So we'll have some cloudy conditions and maybe some showers around, especially if you're looking at the radar tomorrow. They're going to be down to the south. So we're going to kind of keep an eye on that. As a result of that, we're looking at 3 rules that we're evaluating. The disturbed weather rule, the cumulus cloud rule, and the thick cloud rule. Those are our main rules that we're concerned with for violating launch constraints tomorrow. And right now, we're at a 40% chance of violating launch constraints. So we got a 60% chance to go. That's what the good story part is. We're above 50. That's good. So we're going to kind of keep an eye on that and watch that front move through tonight. We'll see the showers move in, start to clear in the morning time frame, watch it all slide to the south, and then we'll see how much of those clouds are left over by the time we get to launch time tomorrow afternoon. In the event we do happen to slip for whatever reason, and it goes further, the front will go further south into southern Florida, maybe even into the Bahamas by the time we get to the Friday time frame. But we got some upper level impulses kind of moving through the flow as we go through Friday. So we're going to see some more shower activity and still some clouds in the area. So I think we're going to see about a probability of violation of 60% as we go through Friday for violating launch constraints on Friday afternoon. And it's the same rules: disturbed weather rule, the thick cloud rule, and the cumulus cloud rule will be our main concerns. So overall, it's a good news, good news story. I think we got a great chance weather-wise to launch tomorrow, and we'll just watch those 3 rules and see how the atmosphere reacts over the next few days. Any questions?
Just raise your hand if you have a question. We'll get you a microphone.
Oh, this is an easy crowd. Thanks.
One question down here. Here we go.
You're going to ruin it.
At what percentage do you guys start considering rescheduling the launch?
Well, normally that's up to the launch directors and the launch authorities. We provide them the weather, and it kind of depends on the weather situation. Most of the time we go into the count, even if we're high probability of violating launch constraints. Sometimes, you know how the weather is, sometimes it can be kind of fickle, and we can find that hole where we're not violating the constraints, and we can actually maybe get a window just long enough to launch. So most of the time, we actually go and start the count, and we wind down and see how the weather's reacting as we go through the count. And then the launch decision authority will make the decision as we're going through the count. We've had opportunities where we've had tropical storms in the region, and we come in, high probability of violating constraints, the weather's bad, and you can just tell that it's not going to lift. And they'll stop the launch or stop the countdown early, and we'll scrub to another day. Other times, we'll go all the way down to the count and see if we can get that launch opportunity and get that hole in the weather. So it'll all depend on how the weather plays out and what the launch authorities decide as we go through the count.
Excellent. One more question here.
So what sort of tools are at your disposal for the localized forecasting? I know you have a general regional forecast, but it's local really important for this. So
Yes. We have a very wide array of weather systems. We have 23 weather systems. Our biggest issue here is lightning. So in the summertime, we have lightning here at KSC 50% of the time. So on Monday, you have lightning. On Tuesday, it's probably about 10 miles away. So most of our unique equipment is focused on lightning. So we have a 3-dimensional lightning mapping array system that we can actually see intra-cloud lightning. And we have our own cloud-to-ground system also that shows us where the actual cloud-to-ground lightning strokes hit the land and where they occur. We also have a field mill system. It's an electric field mill system. It actually measures the electric field in the atmosphere. One thing that we're worried about is natural lightning, of course, but what a lot of folks don't realize is we also worry about triggered lightning. So the electric field mills tell us when the electric field in the atmosphere gets high enough, and it's high enough not to cause a natural lightning strike or stroke, but it actually is high enough that once you introduce a rocket into that atmosphere, it will trigger a lightning stroke. And you actually get a lightning stroke that hits the rocket and damages the rocket. So we have a field mill system that's very unique to us also that provides us that information.
Excellent. We've got time for one more question here.
Hi, I have a question coming in from my audience. Brett Walsh wants to know how many launches there were already this year.
I'm going to have to defer that one. I'm not sure exactly the count as far as launches this year. Sorry, I don't have the answer to that one.
Not a problem. We'll work to get you an answer here. So, all right. So we're hoping for a good news story tomorrow with the weather,
That's
and those good newses are hopefully going to become even more good news as the day goes on tomorrow. So definitely, thank you so very much. Up next here, we're going to hear from the Deputy Chief Scientist for the International Space Station, here to tell us a little about the International Space Station program and some of the science that's going to be going up this time on the Cygnus spacecraft. So without any further ado, here is Dr. Kurt Costello. Welcome.
Thank you. Is this on? Okay, great. Hello, everybody. How are you doing today? Good. First of all, I'm here to talk about the ISS. And the ISS is an interesting NASA vehicle. NASA's in the game of space exploration. And the ISS is an interesting vehicle because it's one of the only vehicles we've designed that really has multiple missions. It's not just there to further our exploration goals, but it's also there as a national laboratory. So what that means for us is we want to get the science there to be able to capitalize on the opportunities in that special environment of low Earth orbit and perform that science, get the results back down to the ground so they can benefit us here on Earth. So again, we've got multiple reasons for the ISS. One, we want to use it to advance our human spaceflight exploration goals. Two, we want to use it as a national laboratory to benefit us here on Earth. We want to establish a low Earth orbit marketplace for the follow-on for station. And we also want to use it to help foster those international relationships that we have aboard space station. And one of the best examples, although not international, of that coming up in this OA4 launch is we even have two college rivals flying together. We've got Texas A&M and UT flying a satellite together. So that's an amazing thing right there. So who knows what can happen in space? So I want to talk a little bit about exploration in science because there are two tasks and goals that are really tied well to one another. If you think about it, you can look at it in a context of maritime exploration. If you go back to the days of Captain Cook around the 1780s, he was sailing the South Pacific, discovering South Pacific islands. That's really a discovery phase. He's out there exploring the unknown, charting it, and bringing it back. It took another 50 years before Charles Darwin then took his ship to the Galapagos Islands, and that's where he got a lot of his theory behind the theory of evolution. So science usually follows on exploration, but it does take some time. The ISS is a great example of that. NASA has been creating space vehicles to do its exploring for years, and now we finally have a full-fledged laboratory in space. It's a multidisciplinary laboratory, and its capabilities are like no national lab on Earth. We go into space for a couple reasons. Primarily, we're there in low Earth orbit looking at the microgravity environment. Things happen differently in the microgravity environment. When you null out the acceleration due to gravity, you get rid of things like buoyancy-driven convection. That changes the way fluids and air flow. That's important in everything from living cells to the human body and into materials processing and fluid processing. Later on, you'll be hearing from Dr. Modal, who will talk about a little bit of the fluid processing that we're doing on space station. So we go there to remove the gravity vector. It makes it easier to model systems when you take away forces that lead to turbidity and other errors that are very difficult to calculate on Earth in a 1G environment. For the particular vantage point that the station gives us. So from low Earth orbit, we cover about 95% of the populated surface of the Earth. And from that vantage point, we have a very good platform to look down at the Earth and also to look out at the stars. So we have a number of external experiments going on all the time. Some of them are focused down on the Earth, trying to determine things like weather, carbon dioxide absorption, other factors that play into our environment. So the ISS can benefit us on the ground in terms of disaster response, being able to image areas because we do fly over them typically once every 3 days or so. And it can also help us because it has a platform that provides power, data, other services that normally would be extremely expensive for a satellite developer to come up with and fly those on a free-flying telescope, say. We can have external payloads attached to our external payload sites, hook up to those utilities, and then be able to fly experimental packages much cheaper than you can if you have to develop the entire platform. So again, what we're trying to do is open up the station not only to the traditional NASA exploration goals, but also the commercial and independent goals for research that benefits here on Earth. Okay? So I just want to leave you with a couple examples of the benefits that we're returning. First comes from protein crystallization. So again, in that fluid and phase change dynamic, we're flying protein solutions to station, and those solutions crystallize once they're left to sit. They do this more slowly in microgravity because, again, you don't have this convection-driven buoyancy. Particles settle out more slowly, and what that leads to are more perfect crystals because you don't include all the impurities in the crystal as it crystallizes. This can lead to better resolution when we get the crystals back on the ground and do X-ray diffraction or neutron diffraction. In one case, this is leading to a potential therapy for Duchenne's muscular dystrophy, which is a disease that affects about 1 in 5,000 boys born. They're typically bedridden or in a wheelchair by age 9, and typical life expectancy isn't more than 20. Our IP partners at JAXA have come up with a potential therapy for this, and they're now in phase 2 clinical trials and human testing. If you're interested in that, I'd suggest you go to their website if you know anybody with the disease. They're looking for additional people. Another potential benefit, we're looking at why spaceflight participants, our astronauts, have vision changes over time. This is crucial to understand as we go out further into exploration what the impacts are going to be on our astronauts if they spend an extended period of time in micro-G. Is it going to affect their eyesight to the point where vision becomes a problem on the surface of Mars or an asteroid? We're looking at investigations now that are trying to understand what are the causes for that. Is it related to the fluid shift that goes on in space because the fluid that normally collects in your legs moves upward in space with no gravity to pull it down? And that can cause pressure on the, in your skull and in the back of your eyes. So we're looking at causes for that and possible treatments for that. One of the investigations we're doing now on the one-year crew is called Fluid Shifts, and it's investigating not only the causes for this, but also possible countermeasures. Okay, and last but not least, I wanted to say, again, we've got those external investigations going on. One of them right now is called RapidScat. It's an ocean wind scatterometer, and it's being used to track ocean winds, particularly during hurricane season. So we can get accurate mappings of the ocean wind vectors from space, and those are being fed real-time into NOAA, or near real-time into NOAA for hurricane prediction. So again, the space station is an amazing place with multiple goals and uses, and we encourage you, if you know anybody who wants to use station, to come approach us or our partners with the National Lab cases. Thank you.
Excellent. So who's got questions here? If you're following along online, you're welcome to ask a question using the hashtag AskNASA, and we've got someone here in the room who's going to make sure that we get those up here to our panelists. So first question, we'll start down here in the front.
What type of progress is being made on sarcopenia and osteopenia? It's similar to the loss of vision mechanically. I know that it's hard to exercise, obviously, in space and create a load on the skeletal system, muscular system. And I've been trying to read up on some of the online literature as to what progress is made there.
Well, as far as creating loads on the muscle system go, we actually do have a device now called the ARED that is a resistive exercise device for the crew, and it's actually extremely beneficial in their health regimen right now. They exercise on it quite frequently, and that has reduced almost to zero most of the issues that we have with muscle wasting and bone density loss over time. That and diet have really helped in those areas. So there are countermeasures on board. That's currently the risk posture that our human research program takes, is to investigate not only the risk, but also to develop countermeasures for spaceflight. What we're looking at in some of the increments coming up will be how to miniaturize those devices, how to make them smaller such that you might be able to take them into an exploration class vehicle like the Orion.
All right, next question's over on that side.
Hi, I got a question from Patrice Mack from Canada, who wants to know, how do you test for vision changes?
We have an OCT device on orbit. We also use ultrasound to look at the back of the eye. Those tests are performed, we get the results, and they're added to the study.
All right, next question's back here.
Can you talk at all about the logistics, how you plan to keep things going on orbit when the supply chain stops, even though it's briefly, not just supplies, but science?
That's a really good question, and I'll answer it from the science side because that's what we do. So every increment, we look at all the potential science that wants to be done, and what we're finding out now is that we have much more demand than we have capability, either through crew time, not quite up mass yet, but definitely in crew time. So what we do is we plan for an entire regiment of science that can be done in the prime crew time, and then a very healthy list of reserve science. So science that is lower priority, but we can get there because we have the up mass to do it, and it can be operated if something happens. That way, if there ever is a skip cycle where we miss a launch or can't get science to the station, we still have science on board to continue. And again, a large part of our science is being done on the crew members. They are the participants, the subjects in a lot of these studies. And as long as they're there, there is significant science we can continue to do. Good, great question.
Yes, hi. Eric Brown with Cosmic Cafe Show. My question is, with the International Space Station, has there been talks or negotiations with China and their space program to start working together and allowing them to come to the space station? Thank you for your answer.
Okay, I will have to officially defer this one to headquarters, but we don't have current negotiations with China going on right now.
All right, we're going to take a question here from Ask NASA.
What do we hope to learn from the Space Automated Bioproduct Lab?
The SABLE. Sorry, I'm going to go into a little acronymese there. The SABLE is actually an incubator. So it is a facility class device that we're sending up to the space station, and it's going to enable future investigations. So what that means is it's an incubator. We send it up there. You can put biological samples into it, keep them at the right temperature, the right gas combinations, and you can also get video back and telemetry back from your experiment. So the SABLE is going up on station to replace some of our older incubators and also to reestablish that capability to run multiple cell line samples, tissue samples, even small plant life and animal life within the confines of that device. So it is a facility, and it's there to support our life science research.
Next question's on the other side.
Hi, yes, with the decommission date of the ISS set to be around 2020 and then the end of life systems for the ECLSS and those kind of getting towards that time, how do you plan on moving forward? You are talking a lot about these projects as you want to plan ahead, and I know Bigelow's wanting to launch their commercial space station. By the time of decommission of the ISS, would NASA have contracted partnership with Bigelow and use their commercial space station for continuing research?
Okay, so a lot of questions there. The space station's been extended through 2024. The president has come out with that decree, and we have our partners coming on board. Russia's on board, Canada's on board through 2024 already. We're working with the other partners to extend their programs out to 2024 as well. So hopefully the horizon is a little bit further out there than 2020. And when it comes to the follow-on, that really is one of the goals. We're trying to understand how to commercialize that low Earth orbit market, make it commercially viable, help people in the startup regimes start to understand it, and have a commercial entity willing to come online whenever station does go away. So it's hard to say when that will actually happen. The structural lifetime looks to be about 2028. Most of the items have been cleared through there, but we'll see what follows on. But hopefully it'll be a commercial space station.
We have time for just a couple more questions here.
Hi, thank you. You mentioned many of the tests are performed on the astronauts themselves. Nutrition is of course, a very important focus long term. And with Commander Kelly and his twin brother at home receiving a lot of simultaneous tests, a lot of the food that's sent up to the space station is, of course, so we see a lot of what they had for Thanksgiving dinner online the other last week. But
I think I saw their stuffing recipe.
Yeah, exactly. So what is the most anticipated, my daughter Hannah in 8th grade wants to know, what's the most anticipated food that's on its way to the space station that might be different from the normal routine?
Typically what works best on these launches is they get their fruit basket. Essentially, fresh fruits, a few fresh veggies are something that's always really exciting to have. Now, of course, we're working to try and help them be able to grow some of their own vegetables on board. You might have seen with the veggie experiment, we did some red romaine lettuce that they were finally able to clear and eat themselves. Right now, they're growing zinnias in the veggie box, so they're hoping to add a little floral arrangement, I think. But certainly, they're probably looking forward to the fresh fruit. They always say when they open up the capsule, that's what they can smell.
Okay, few last questions. Yep.
As you mentioned, it was the ISS is a fully functional science laboratory. I was wondering how many science experiments are currently happening on board, and which one has surfaced to be one of the more favorable experiments.
For any given increment, and an increment is a 6-month crew period, we plan between 200 and 300 investigations across the entire partnership. Typically, we have around 250-ish going on at any single time. And that's our automated investigations, all the human research going on, the various payloads in the racks themselves. One of the new and upcoming areas is certainly protein crystal growth. There's been a lot of commercial interest in looking at growing protein crystals in space to diffract here on Earth, either in X-ray or neutron diffraction. And those are targeted at early stage drug development and trying to narrow the pipeline.
All right, one last question here.
Thank you. Thank you. With ISS as the host for all the scientific experiments, and knowing that obsolescence is something that happens over time, is there an advanced team at NASA or elsewhere that's looking into a replacement for ISS in the future, with new technological advances as such that could be incorporated into a new host, so to speak?
I guess the best way to answer that is NASA's stated goal is to go out and continue our exploration further out into the solar system. So the follow-on, should it be some waypoint at Lagrangian point near the moon, or somewhere as a station keeping and testing site, may be a follow-on laboratory. And there are people who are looking at what capabilities that might have. But as far as replacing a low Earth orbit orbital platform, we're really hoping that the commercial industry can step up to take on that challenge. Yeah. Thank you.
All right, wonderful. That's all the time we have with Kurt today. Thank you very much for joining us. If you want to keep following along with what's going on social media with the International Space Station, you can follow them on social media, either at ISS on Instagram, or you can follow them at space_station on Twitter. If you want to follow along with what's going on with the research program specifically, you can follow them on Twitter at ISS_research. Next up, we've got a special treat. We're going to hear a little bit about the rocket and the spacecraft that's going to be launching tomorrow. So joining us from the United Launch Alliance to talk about the rocket is Matt Donovan. And then joining us from Orbital ATK is Andrew Zarenchnek. So take it away. We're going to hear a little bit about the hardware that's going up tomorrow.
Hey everybody, I'm Andrew.
And I'm Matt.
How's it going? So I guess I'll just talk to you a little bit about the spacecraft, and Matt will talk to you about the rocket. So my name's Andrew, and I work for Orbital ATK, and I'm fortunate enough to be on the team to prepare, design, deliver the Cygnus spacecraft to the International Space Station aboard the ULA Atlas V launch vehicle. So my role is I'm the launch vehicle interface manager and launch site interface manager. And so what that means is we go to the rocket and say, here's what we need to do to fly to orbit. Here's the mass, and here's the dimensions. Here's the parameters. We got to make sure that we're compatible initially on flying, on getting delivered to the space station. And so we go through that process of compatibility. And in this case, we had a pretty short time frame, and typically you have about 2 years to prepare for flight with a launch vehicle and with a spacecraft. That's about how much time it takes to build from scratch, design and build the spacecraft from concept to space. Is about 2 years, is about as good as you can do. Fortunately, we had the spacecraft ready to go. We had a little pause with our rocket, and so we needed to find a new one temporarily. We went to ULA, And within a year, from kickoff to launch, we kicked off December, I think it was 20th. So in less than a year, we're going to be able to launch December 3rd, Thursday, into flight. And so it's been a long, kind of intense preparation path over the last year to prove that compatibility, to do all the analysis, do all the testing, the interface testing, to get us to where we can now ready to launch. Through the last readiness reviews, we've proved that all of the I's are dotted, T's are crossed, and we're ready to go launch on this Thursday. So I think I'll go ahead and show you a little video of what we've done here in the last 2 months. Last 2 months is what happens is we bring our spacecraft to the launch site. We have a pressurized cargo module that is built by the Thales Alenia in Italy, and then the service module that we build at Orbital Dulles, Virginia. And those are the two halves of the spacecraft. And so the service module is the brains of the spacecraft. It has all the propulsion, it has the computer systems, the comm, the thermal, all the systems that basically drive the spacecraft. And so we build that at Dulles, ship it here to the Kennedy Space Center, and process it at the facilities here. And then the Italians, they build the pressurized cargo module. That's what holds the cargo, the precious cargo that the astronauts use to do the science that he was talking about, to eat, to fix the systems on the station. And so the PCM, the pressurized cargo module, gets delivered to Kennedy Space Center, and the service module gets delivered. NASA delivers the cargo. We load the cargo into the pressurized cargo module, and we mate the two halves. We test the whole system out, fuel it up, bring it to the rocket, and then he takes it and delivers it us to orbit. So let me go ahead and, so I guess it's playing here. This is a service module, and this is testing at our facility. We have new solar arrays on this mission that we haven't ever flown before. And you can see how they unfurl and they rotate. So that's a new technology that we are bringing onto this spacecraft for this mission that we hadn't previously flown. And here's a service module that's essentially complete and ready to ship. This now is the pressurized cargo module, the PCM, that we talked about, just being delivered to the SSPF, the facility at the Kennedy Space Center. And you can see the service module arriving, and it gets placed. And here's loading of the cargo. One thing that's nice about our PCM is it's got a lot of volume, so you can fit a lot of big bags. NASA likes to have the flexibility of flying a lot of big things, and so we can, those MO3 bags, there's different size, MO3, MO2, MO1, and so the big bags fit well into our vehicle. So we load it all up, initial cargo load is done. We rotate that PCM vertical, we go mate it to the service module here, put the two halves together, and then we transport over to the fueling facility. And the fueling facility is just a mile down the road over at Kennedy Space Center. And at the PHSF, after fueling, we have also a late cargo load. NASA likes the ability to, very late in the flow, be able to load things into the vehicle. For example, if there's something that broke on station and they needed to fix that, late in the flow, we can add something to the vehicle. The fresh food also comes in late. Then we encapsulate, that's the ULA fairing that encapsulates the Cygnus spacecraft. Just happened just a couple weeks ago. That's our logo on the fairing. And then from there, it gets shipped over to the rocket at the VIF. And that's just about a week ago we made it. That was an exciting day, seeing the Cygnus lifted up onto the rocket. I took a nice photo of myself. I said, "We made a rocket today." So that was a good day. Got a lot of likes on that one. So anyway, and you can take over and say what happens next.
Great, thanks a lot, Andrew. My name is Matt Donovan. I'm the leader of our Human Launch Services propulsion team. So we do propulsion design, propulsion analysis, work on the mechanical ground support equipment, ordnance systems, and other aspects as ULA transitions into this human launch services business. So very excited from a United Launch Alliance perspective to be able to work with our partners at Orbital ATK and be able to take cargo to the International Space Station. Very exciting for us. So you talked a little bit about the rocket. The rocket we're going to be flying for this mission is in what we call the 401 configuration. That means a 4-meter diameter payload fairing. We have 0 SRBs required, and we're going to have 1 engine on the second stage to be able to power us up and get them on their way to station. So that's a little bit of that from a United Launch Alliance perspective. We're going to be using the Atlas V. We also have a Delta IV and Delta II launch vehicles that we use for other launches. This is going to be our 12th launch this year. Somebody was asking earlier, from our perspective, this is our 10th launch out of the Cape across all of our different vehicle families. So very excited, very busy year for us, and it's a fantastic way for us to cap off the year with this OA4 launch. So I actually have a video for you as well, just giving you a quick overview of what the mission's going to look like that you're going to see launching hopefully tomorrow.
The following profile details the important events of this mission using approximate times.
5, 4, 3. We have Atlas ignition. 2, 1, 0, and liftoff. We have liftoff of the Atlas V rocket carrying.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 83 seconds. At 94 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,350 pounds per second, traveling at approximately 10,000 miles per hour, and located 79 miles in altitude and 172 miles downrange. Booster engine cutoff occurs 4 minutes and 15 seconds after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4 minutes and 40 seconds into the flight. Cutoff of the Centaur main engine follows a nearly 14-minute burn. The mission now enters a short coast in preparation for spacecraft separation. At just over 21 minutes, Centaur releases the Cygnus spacecraft for orbital ATK and NASA.
So that's just a brief preview of the mission that we've got coming up. Heard earlier, the 21 minutes that you heard to spacecraft separation is faster than you can get a pizza most places, and we'll be getting them on their way to station. So nice short mission. We'll be deorbiting Centaur with a second burn following that. Putting that down in the ocean. But yeah, very excited to be able to participate in this mission with Orbital ATK and support the International Space Station.
All right, with that, we've got time for some questions here. So we'll go first question over here.
I was just curious, what is the anticipated arrival date for the payload?
So assuming we get off this Thursday, the 3rd, we should be berthing on the 6th. So it's about 2.5, 3 days to get to station.
Yeah, I'm curious if there was any changes that were required to be made to Cygnus or Atlas to support this, or was it entirely a certification process to get working together?
That's a good question. We really didn't have to make any fundamental changes to either the spacecraft or the launch vehicle. There were some very minor things. The one area that required minor changes was our blankets. So the venting analysis took some time to get to the point to where we were compatible. So we had to adjust our holes, but it was very minor adjustments to the blankets, an inexpensive change. So essentially we were compatible. We were designed from the start, Cygnus, to be compatible with multiple launch vehicles, at least at a high level, and then you got to get into the details to confirm that. And so we found some minor things that we had to adjust, but no significant detail changes on the Cygnus side. On the launch vehicle side, they did have to build a unique payload adapter for us. So that payload adapter was had to be designed very quickly, and they did a fantastic job of putting that together. And then on the umbilical side, there were some changes that they had to do. There's some unique umbilicals on their side that they had to prepare for us and test out. So those are the two probably most significant things: the payload adapter and the umbilicals that were mission unique to our flight.
Yeah, and I'll add to that from a hardware perspective. I think Andrew captured it. The other unique thing is what we're able to do as far as launch windows. With the capability that we have on Atlas V and the performance, we were able to give them a longer launch window. Most of these missions to station have an instantaneous launch window. So you have 1 second to launch, and if it's bad weather, you have something that comes up, you're scrubbing to the next day. With the performance that we're able to provide with an Atlas V and our fantastic trajectory and performance team, they were able to design multiple mission profiles to be able to give us 5 launch periods that we're going to have tomorrow, which gives us an extended launch window. So when you talk about things like weather, when you have things that come up during the countdown, it gives us a lot more flexibility to be able to support hopefully launching them tomorrow. So that was the other really exciting thing from our end that we're able to do for this mission.
That's a real good point. A 30-minute window is the longest window that any vehicle flying a station has been able to do. So that's a great thing for the Atlas V to be able to do for us.
Wonderful. Just a reminder for those who are watching online, we're taking questions using the hashtag AskNASA for members of our panel up here. Next question.
Hello, I just wanted to know the specifics of the experiments that are delivering to the ISS.
So I might defer that to the NASA folks, but I don't have a lot of details. I know that there are food, there's science experiments, there's crew hardware, there's some laptops, there's some EVA equipment, there's some EVA suits for spacewalks that the astronauts need to fly, and so there are some replacement parts and new parts that they're going to fly in our vehicle. Those are the details I'm aware of. I don't know if you know any other specifics about our mission, but those are the ones I'm aware of.
Yeah, I'll add to that. One of the ones we're really excited about is there's some fire extinguishers that were developed by Colorado School of Mines just up the road from us and our engineering headquarters in Denver. One of the guys on my team actually, as part of his graduate studies, worked on the development of these unique fire extinguishers that we're delivering to the International Space Station. So it's great to be able to see the partnerships that we've made with local universities and schools come into fruition now with something like that we're able to fly on Cygnus to the International Space Station.
I did also remember that there is with every mission, there's some family packs, and so we're also sort of, I heard Frank Culbertson say we're sort of a Santa Claus. We're going to be delivering some Christmas presents to the crew. So the family members do get a small percentage of the cargo, and so we'll be delivering Christmas presents to those. Our primary customers are astronauts on board, so they do get a little bit of Christmas presents on the way. But I can't give away what they are.
Hi, what was the motivation for changing the solar arrays? What are the benefits? Lighter weight, increased output?
Primarily it was lighter weight. There's a couple things. It's lighter weight. The cost was also a potential consideration, and the third consideration is it's ATK. At the time it was a separate company, Orbital and ATK merged about a year ago, but prior to that we made, so now it's an in-house solar array, which is Orbital ATK. So those are the three primary reasons that we made the change.
All right, next question.
I wonder if you could talk a little bit about the loading process for cargo. It's obviously not like throwing a bunch of suitcases in your station wagon. You know, how do you work that out, especially with the late stage requirements NASA has for fresh fruit and that sort of thing?
So yeah, that's a good question. So it's not like loading an airplane. So we have specific requirements for the mass. We have to keep the thing very light. And so to do that, we've had to make modifications actually to our spacecraft to reduce the internal secondary structure within inside the vehicle. And so we now have cargo nets inside the vehicle. And so we have a crane. You might have seen the video. There's a crane that picks up the big bags and puts them in. The smaller bags you can take by hand and put them in. And the bigger ones, there's a small crane that picks them up and puts them in. We call it the R-pit. That's its nickname. So you have a guy inside that receives that bag, puts it in the right spot, and then has to strap in that bag. And so it's a long process. It takes about 5 days just for the initial load. That's the non-time sensitive cargo, to load all of that and get it strapped in perfectly. Everything's got to be just right. You're going to get a pretty, a ride on the rocket that vibrates you pretty good. So you got to make sure you're very secure. And so that takes time. And so there's a crane, there's people in there that strap it in, and there's a net that goes on top. And then the late cargo, you talked about being able to do. So we do it at the very last minute, just before encapsulation. So we have, after fueling, the very last thing we do is open up that hatch again and do the same process with the same nets and load them in until just prior to encapsulation. So that's the process we use to load the cargo.
Other questions?
How durable are the new solar panels, and are they going to be reusable?
They're not. Everything on the vehicle is one time. One of the benefits that we provide actually with this spacecraft is, it may not be glamorous, but there's a lot of trash that needs to come off the station. And so we take a good significant amount of trash from the ISS and we burn it up through a destructive controlled reentry into the station. So there's nothing reusable. It's all single use.
One last.
So I had a question where somebody wanted to know how many Earth rotations it takes for to arrive to the ISS.
Okay, you're going to make me do math in public here. So it's about 3 days, and so you multiply 3 in how many orbits are in? 16 orbits, I believe it is, per day. So 3 times 16, what is that? About 40, a little more than 45. So about that many orbits to get to station.
Wonderful. We got time for one last question. One last question? Anyone? Going once? Going twice? All right. Thank you both for coming and talking about the rocket and the spacecraft. Good luck with launch tomorrow.
Thanks a lot. Thank you.
All right, next up, we're going to hear a quick little video here from one of our partners on the International Space Station here. CASIS, which is running the National Laboratory on board, has some science experiments that they're going to be flying in Cygnus. And so we've got a little video talking about one of those experiments.
We go around to many industries all over the country. We're in front of some of the top R&D people at the biggest companies in the world. And these folks, once they see about what they can do in microgravity, they get a ton of project ideas. Like the folks here at Millikan, they're developing a flame-retardant textile for clothing that a lot of people will wear.
We're trying to design and engineer, put on the right chemicals such that the textiles don't burn. So this is, think of, for the military, an IED. Think of a firefighter when they're going into a burning building. And it's really, again, trying to protect the person so they don't get second and third degree burns. We try to use unique insights and meaningful design and deep science to deliver a good to the world and to our customer.
So they're flame retardant textiles that they're trying to develop. Seeing what happens when they burn without gravity is very important, because gravity gets in the way of a lot of other phenomena. So when they see that, they can really understand what's going on and apply that back down to their processing on Earth.
It's really nice to have a lot of camera and digital work up there so we can look how it burns, and then we're going to get the samples back, bring them here, and then take them through a litany of analysis methods so we can find out how hot the flame was, all kinds of good nerdy stuff. I mean, ultimately, we want to deliver an innovative solution to the market. We want to protect people, and we want to have the best product out there that lasts the longest.
So this can really save lives, and that touches home to everyone. So that's why it's a great partnership to work with Millikan, because the goals of their project and the goals of our mission align very, very well.
So also flying on board are a lot of other science experiments, and today we're going to hear from one of the principal investigators of the PBRE experiment who joins us. He's from NASA's Glenn Research Center, and this is Brian Model, and he's the principal investigator for PBRE.
Thank you, and good morning. So I understand most folks here got invited, and you're probably pretty excited to be here, but I want to say that I've been working on this experiment. I conceived this experiment about 16, 17 years ago. So I'm really excited to be here. I'm finally getting this thing up there. So I started at NASA 26, 27 years ago, and I actually started working on a space station. My first job was working on a thermal control system for the space station. And what I find kind of interesting is after that, I worked there for about 4 or 5 years, and then I moved over. At the time, Glenn Research Center had responsibility for all the intermediate and large unmanned launch vehicles. And I got assigned to designing a new pressurization system for the Atlas V, and actually got to work on that. And I think it's kind of cool that that's going to be taking my experiment up. One of the highlights of my career was crawling around in the business end of an Atlas V years ago. This was actually, we were working with General Dynamics at the time. Crawling around in the business end of the Atlas V, doing our final inspection, and then seeing that take off. It was a GOES satellite that we were launching. It was a lot of fun. But if I could, I have a few picture slides I want to show you, so if you bring the first one up. This is our patch. And we have a number of partners. The experiment is led by Glenn, but we also have a co-I, Professor Balakataya from University of Houston, And we're working with NASA Johnson Space Flight Center and Marshall Space Flight Center. Zinn Technologies is a local contractor who built the flight hardware, so I want to recognize them. Show the next slide. So a little background on what a packed bed reactor is, okay? It's actually one of the most common reactors, class of reactors in industry today. In fact, about 80% of all reactors fall under this classification. And as you see in this picture, there's a number of different types of packing, shapes, sizes, and purposes. And this is just a few of them. The packing, the solid packing being used typically it's used as a catalyst for a reaction. It could be a host for biological media, or it could simply be there just to mix up the gas and liquid to enhance the reaction as it flows through the column. Next chart, please. So the types of reactors can be broken down into these classifications. There's a whole class of suspended, fluidized type beds which require gravity really to function. So we're not even looking at those. On the fixed bed side, which is where the packing, the solid packing is held solid. It's not allowed to move around in the bed. There are also a number of classifications you can see there. And I want to get down to the bottom. The bubble and pulse flow that are highlighted in red there are really the two types of flow regimes that behave very differently when you go to 0G, to space, than they do on Earth. And I'll show you a video at the end of what that looks like on one of our early experiments on the, that we did on the aircraft. Some of the other types of flows that you get are either there's very little difference when you go to space, or they can't exist at all, like trickle flow. Okay, next chart, please. So why are we doing this? One of the keys, and I think most of you know this, mass savings is really critical to long duration space flight. So we have got to recycle pretty much everything we take: water, air, and even trash. And today, I think we have about, we recycle something on the order of about 93% of our water on space station, and I think it's about 50% of our air. We'd like to, in fact, as you can see, what this chart is trying to show is that the longer you go, the more cost effective it is to invest in equipment to do the recycling rather than taking the consumables with you. And the water is, I think we consume something like over 20 times more mass per day in water than anything else, in air or any of the other consumables. So this particular technology is really focusing on getting that water recycled to almost to a complete 100%. Next chart. So this shows that kind of the cycle and all the different processes that you have to go through to fully reclaim water in space. And the reason I want to show this is every one of those boxes, there's a packed bed reactor or some sort of a reactor bed in there. On the early wastewater treatment primary processor, there's two-phase. There could be a biological reactor. There's a number of other types of systems we use. And when you get over to the post-processing and even the disinfection phase, we have single-phase reactors, which are not, a single-phase reactor isn't influenced as much by gravity, but what we found is that over time, bubbles accumulate in these systems, and they get trapped in these beds, and they start to take up volume, and the reactor bed loses its efficiency. So we're actually going to be looking at how do we remove those bubbles. That'll be another aspect of this experiment. Okay, next chart. So this is sort of the history. Up on your upper left was the very first experiment that where I wanted to just see what would happen. Nobody had looked at this before, so we built a drop tower experiment. We saw that there was an effect going to microgravity, but we only have 2 seconds to see that, so it didn't really develop too much. And then as you go down and up to your right, those were a series of zero-G aircraft experiments that we built and flew over the years. And we have, if you go to the final chart, next, okay, this is our flight experiment. This is what we're launching tomorrow. It'll be in the microgravity science glove box. It's actually going to be launched in pieces like that, and right in front is the reactor bed. That entire bed it's heavily instrumented. We're looking at all aspects of the flow dynamics in this bed. Is removable. So we have two different systems. We're going to be looking at two different types of packing. What's really cool about this experiment too is that all that section with all the instrumentation can be removed, and the rest of the system can provide a gas-liquid flow facility for any other types of experiments. So if somebody wants to look at a different type of bed or even a fitting or other component, they'll be able to come up later and use this system. So the last thing I want to show you is a quick video of what it looks like in space. Okay, so this is off of our aircraft, and this is the bubble flow regime, and you can see this is slowed down. This is taken at high speed and it's being played back at a normal speed, but you see how well distributed the bubbles are. They tend to get trapped. In gravity, they would want to rise up depending on the orientation of the bed. And this is really interesting. This is what we call a pulse flow regime. This is actually a natural condition in a bed. You can get this type of flow in 1G, but you have to go at very high flow rates, and it's difficult. It's such a high flow rate that it's difficult really to get much of a reaction. One of the interesting things we found on our aircraft tests is that we can get pulse flow at a much lower flow rate. So what we're pushing is that this is a type of way we could operate a bed in space that you can't on Earth, and actually get a more efficient bed when you go to space. That's all I have, and I guess I'll take some questions.
Indeed. If you have a question, remember, if you're following along online, you can ask it using the hashtag AskNASA. Otherwise, here in the room, just wait for a microphone. Do we have any questions for Brian?
Hi, yes. I have a question from a fellow engineer named Nick Mismansky, and he would like to know, because you guys are focused on the astronauts having reusable resources that are obviously easy to access, has it been a consideration for you to view the moon base as a necessary stop, as the first stop in interplanetary colonization? I can talk today, I apologize.
Okay, so that's way above my pay grade. But I will say that we are certainly, this type of a bed is, can be used in space. It can be used on a lunar outpost. It can be used in Mars, in a Mars mission. We're very interested in, if taking a bed that's operating in 0G and then putting into a partial G environment, like on the moon or Mars, and how will that behave? We can't, we won't be able to test that on the space station, but we can do some preliminary testing with the aircraft, which we're considering doing.
Just a clarification, are there a particular reaction or set of reactions you're going for, or is it more just studying like how the system works?
Good, sorry, I should have explained it a little better. There's actually no reaction going on in this bed. What we're looking at is the hydrodynamics, how the phases interact and behave. If we give the pressure drop and how the phases are mixing and based on an input on a flow rate, we give all that to a chemical engineer. That's really the key of what they need to know. Okay, they can the mass transfer, the actual reaction, they can calculate fairly easy, and there's really no difference in 0G versus 1G. So the real key is the hydrodynamics, and that's what we're focusing on.
Next question. All right, I've got one for you all, taking moderator privilege here. You've been working on this for 16 years and so on. So what are you most excited about? What's going to go through your mind on launch day here?
Wow. Well, first of all, that it gets up there safely. No, it's just so cool. I don't know. you know, I'm really excited to come down here. One of the things is, you know, we've got a test matrix that we constantly keep tweaking. So I'm glad to get away from that and stop thinking about that. You know, I'm just hoping it gets up there, and I can't wait till they turn that switch on. We're going to be operating it for about 10 weeks. So we'll be, that'll be an exciting, you know, 8 to 10 weeks that we operate.
Great. Any last questions? All right, then. Thank you very much for joining us.
Okay, thank you.
Thank you. And good luck with your experiments and the launch tomorrow. All right, next up we have Andy Petro from NASA's Small Satellites Technologies program here. And he's going to talk about some of the little satellites that are going to be riding along tomorrow on the launch.
Right, thank you. Yeah, so I'm the from the Space Technology Organization at NASA headquarters, and I oversee both our small spacecraft technology program and also our solar electric propulsion program. So I deal with some of the biggest stuff we're thinking of putting into space, as well as some of the smallest. The great thing about CubeSats is I don't have a scale model here. I have the actual spacecraft. This is an engineering unit of one of the two nodes CubeSats that we're going to be launching as cargo tomorrow up to the space station. These will go up with a bunch of other small spacecraft in the NanoRacks dispenser, and then once they arrive at the station, they will later be put out through the airlock and deployed into orbit. So we're really excited about that. I'll come back to this in a moment. I just wanted to provide a little bit of context. And I think if you look at all of the different satellites that are going to be going up as part of this package on this launch, you see the full spectrum of things that you can do with these small satellites, especially the CubeSats. They're obviously valuable as an educational tool. You'll see there are university projects built around using these spacecraft. There's even school children have built a CubeSat. But from our perspective, we want to emphasize the fact that these are real tools for engineering and science. This particular one was built by engineers at the Ames Research Center. And we have projects in the next few months in which we will demonstrate laser communication with a CubeSat of the same size. That's the project being done by the Aerospace Corporation. There'll actually be two of those. They will demonstrate laser communication from orbit back to the ground. They will also be tracking each other and will be doing formation flight. They will have a propulsion system, and they were going to try to maneuver within 200 meters of each other in orbit. Again, with a CubeSat of that scale. I think nothing like that has been done on that scale before. We'll also be having a set of 3U CubeSats. This is a project being done by TIVAC under contract to our program. They will demonstrate autonomous rendezvous and docking of 2 CubeSats in orbit. Both those missions are coming early in 2016. Another one being done by JPL is going to demonstrate a high-gain antenna on a CubeSat using a deployable solar array, and the back of the array is then used as the high-gain antenna to demonstrate getting very high data rates from a CubeSat scale vehicle back to Earth. What's exciting about that is, as we are just getting prepared to launch that, that technology has already been infused into a NASA mission coming very close behind it, which is the InSight mission to Mars. That's going to carry 2 CubeSats that have been developed by the Jet Propulsion Lab that will use this particular type of reflect array, which is the high-gain antenna that we are demonstrating with our CubeSat project, will be on a mission to Mars in the coming year as well. So that's the kind of thing we want to see happen with this technology development work that we do. Now, getting back to nodes, again, this is a 1.5U CubeSat built by the Ames Research Center. The instrument inside, which measures high-energy particles in space, was designed and built by the Montana State University. And the whole mission will be controlled on the ground by students at Santa Clara University. So we have a good collaboration between NASA engineers and the academic community on this particular mission. What's sort of interesting about this, just to explain what it's going to do, as I said, it'll be measuring the high energy particles in the space environment. The two of them, of course, will be taking those measurements at two different places in space. They will share that information back and forth between them using the UHF radio. These are the antennas for that radio. So they talk to each other on a regular basis, and then one of them, and it can be either one, will relay it to the ground. And they will determine between themselves which one will have the best communications pass on a day-by-day basis, and will make that decision and automatically relay that to the ground. And they also have two-way communication, so we can send commands to either one of them and relay those to each other. This is actually a companion mission that we came up with somewhat after the fact to the Edison mission, which was the same spacecraft, but with 8 of these, launched as a group, doing what I was just saying, each of them taking these measurements, sharing them among each other, and then one of them, any one of them can relay it to the ground. The value of that is you can now operate a fairly large constellation of satellites in space and only have to talk to one of them in order to get the data from all of them. And that would enable a lot of different kinds of science missions that we might like to do in the future. And of course, what also makes that possible is that each of these is a very low-cost satellite. The unique feature of this is it's using a off-the-shelf commercial smartphone as the computer. That's the brain of the satellite. So keeps the cost very low, allows us to take advantage of all that past research that the government invested in that created these electronic devices that we all use every day. We take that spin-off technology, turn it back around, and use it in our own spacecraft to make them a low-cost alternative way of doing science and engineering in space. So I think I'll take questions if you have any.
Questions?
I was interested in how they're powered. Are those micro solar arrays, or are they battery powered internally?
Yeah, it has rechargeable batteries, and these are solar panels on the outside. Interesting thing about this, another one of these great CubeSat things, is that there's a company in California that buys scraps of solar panels from the big ones that are made. So these are very high efficiency, very high value solar cell panels, but they're just the scraps that would normally be thrown away. This company buys them up, puts them on boards, and sells them. One panel is about $150, I believe, and that's a 28% efficiency solar cell. So it's good stuff at a very low price, and that's the kind of thing. And you can see the antenna as well. So it's a deployable antenna, but you can buy it in a hardware store. And that's, no reason to spend more than we need to.
All right, next question's down front here.
At what data rate is a signal going down to Earth?
With the this has an S-band antenna, and that's about 10 kilobits per second. So fairly low for this. That's why we're interested in the laser comm that could get up to hundreds of megabits per second. And even the high gain antenna that we'll be testing would be in the hundreds of megabits per second. So right now there's a limitation on communication with these small satellites. I think we will rapidly see that change, and that will no longer really be a limitation.
All right, just a reminder for our followers online who are watching, we're taking questions using the hashtag AskNASA, and we're going to go to one of those questions now.
The question is, how can high school students get involved in CubeSat creation?
I think there's probably some other guests here this week that could better answer that. But there are programs across the country. I mentioned 2 things. One is that NASA provides launch opportunities for those types of projects, and we'll be doing that. That's how some of these are being flown even this week. Our focus, of course, is on engineering and science, developing these capabilities for our science exploration and space operations missions. But we obviously recognize the tremendous value of this as an educational tool. We also have, our program does have a collaboration program with universities where we take proposals from universities and then match them with a NASA collaborator to do projects. And we've had a number of those going on over the past few years, and we intend to do that opportunity every year.
Next question's over here in the back.
Yes, hello. Eric Brown with Cosmic Cafe Show. My question is, since you mentioned that the brain of it is cell phone technology, and not to maybe perpetuate the rivalry between OS and Android, which cell phone brain technology is being used, if you don't mind answering?
Yeah, they're using Android. And I believe the reason is just the accessibility for doing programming with it. I'm not a software expert, but that's what the team members chose to do. But what's inside is just the board taken out of a phone that's bought off the shelf. So they go out and buy them and take them out of the box. And then the original phone sats that tested this technology a couple of years ago on a couple of missions that we sponsored had literally the phone inside the cube. But then they've kind of progressed to taking that out. But they use a lot of the components. On those phone sats, they even used the camera from the phone to take pictures of the Earth and send those back.
Next question's down front here.
I was curious, since yesterday we've heard several times the term off the shelf, and I was always under the impression that most of the things that we used here for missions were custom built for the missions. So my question would be, what percentage are we looking now for the projects that we have that are now going to be off the shelf, so to speak?
I think we'll always see a mix. And to me, the ideal thing is you have a satellite bus, that is using mainly off-the-shelf types of things as much as possible. And then you're introducing to that the unique things that you want to be using either as instruments for your mission or new technology that you're testing. So I see it, there'll always be, I think, a little bit of a mix there. But we can make, I think, a satellite bus for, a few $1,000s.
All right, next question's down here in front.
Thank you. I see a huge potential related to communication to this technology. Is this the starting phase of lower orbit internet, so to speak? I see also some spacecrafts that are deep space dropping these boxes along the way so that it relays communication back. So are there plans on expanding to this type of level?
Yeah, well, the Marco mission as part of InSight is an example of dropping them and use them as a communications relay. There's, I've been talking about our NASA research, but there's a huge commercial activity out there. You have companies building these by the dozen, and with all kinds of ideas of how they might build networks around the Earth for that, all kinds of communications.
All right, we've got time for one more question.
I was just curious, what do you do about thermal protection for the phone inside the CubeSat?
Yeah,
thermal management.
Yeah, what we found with the original PhoneSat missions that were looking at that particular problem, they didn't really need to do very much. These satellites, it's aluminum frame. The heat kind of dissipates into the structure, and it wasn't really a problem. As we get to higher and higher power systems, which is what we want to do, we have to begin to be concerned about thermal control. So that's an area of technology we're beginning to put a little more attention. We've been focused on communications, propulsion. We're going to starting to look at more power, and then once you have more power, how you deal with heat rejection that goes with that. I will be around after the program's over if people want to look at this up close or talk some more as well.
Wonderful. Thank you very much for joining us today and telling us about it, and good luck with launch tomorrow.
Thank you.
All right, so we're here at the Kennedy Space Center in order to see this launch that's happening tomorrow here. And so who better to tell us a little bit about what's going on right now to prepare for the future here at America's Spaceport than the director of Kennedy Space Center, Bob Cabana.
Hey, good morning. Hope you're all having a good day so far. So I was just out at the beach house talking to our legislative affairs folks, and I was driving back. You know, I drive past all the launch pads, and I was contemplating the tremendous positive change that has gone on here at KSC in the last 4 years. And it starts right there at pad 41, right out by the beach house. And I'm looking at the pad, and tomorrow we'll see an Atlas V on it with the Cygnus vehicle, which was processed and fueled right here at the Kennedy Space Center before it was put on top of that Atlas V. But out there on that pad, you see this huge vertical structure on the pad that wasn't there just a few months ago. And that is the access for the crew to the Atlas V for the CST-100 Starliner spacecraft that Boeing is going to take crews to the International Space Station on. Hopefully we'll have a test flight in 2017 with crews flying it in 2018. And, you know, just back behind us here in OPF Bay 3, you see that huge Boeing logo on the front of it. And what was an orbiter processing facility and engine shop for the shuttle is now the processing facility for Boeing's crew module, command module, and service module. What a great way to utilize excess facilities to enable commercial space operations. So then I passed pad 41, and the next pad I come to is pad 39A, which could have been just rusting away out there in the salt air, but instead, what do you see? You see this huge horizontal processing facility that SpaceX has built for the Falcon 9 and Falcon 9 Heavy. The pad, totally redone. It's got the transporter erector out on it, you know, totally refurbished to accommodate the Falcon 9 Heavy and their commercial crew entrant, the Falcon 9 with the Crew Dragon on it, you know, hopefully flying a test flight in 2017 with crews to the space station in 2018. That's pad A. Then you go a little further, and I took a spin around pad B, and, you know, we're going to Mars from pad B. You know, they're working on the flame trench right now, new flame trench, new flame deflector, but most of the refurbishment is complete on that pad. We just need a rocket. And I just can't wait until we get a SLS out on pad B, even for the initial integration and testing. It's going to be awesome. So then I went back up the Crawlerway Road, and I see the doors open on High Bay 3 and a VAB, because what's going on in there? You know, it's totally gutted. They're getting ready to install the platforms for SLS in there. And the platforms are arriving. You can see them out in the park site outside the VAB, and maybe I'll get a Christmas present, and the first one will be installed by Christmas. But what a great design. You know, this rocket is going to evolve. You know, the SLS starts out on EM1, but it's going to evolve to a bigger rocket. And these platforms, they move 8 to 10 feet up and down. They have inserts in them so that as the outer mold line of the rocket changes, you don't have to change the whole platform. You just remove the insert, put a different insert in to accommodate SLS as it evolves. That's going on right now. And then I took a picture of the mobile launcher right outside. There's a crane by it. And the reason that crane is there is because we've completed all the structural mods to that launcher. We're now installing the swing arms and the umbilicals and the systems that are needed to support the Space Launch System. And that is happening right now. Over in the Launch Environment Test Facility, back behind the ONC building, is, you know, the swing arms and umbilicals have started to arrive. They were built by a small company right here in Cocoa, Florida, Coastal Steel. And they've got the big one for the interim cryo upper stage installed. They've tested the one for the service module. It's awesome. This is real testing, real work that's going on right now. And change is happening, and it's a very positive change. We're enabling commercial operations, and we're also enabling the United States to explore beyond planet Earth again. You know, I get really excited. I look at, you know, NASA, we've been #1 in the federal government 3 years in a row, and hopefully this will be the 4th year. And I ask, why is that? Why is NASA #1? And I think there's a couple of reasons. First off, we have an amazing team. You know, people, we really do believe in the NASA family, and we look out for one another, and we create an environment where NASA is a great place to work. But I think one of the main reasons we're always #1 is we have a meaningful mission. I mean, we come to work every day, and we're not just making a difference for the United States, we're making a difference for the world, for humanity, you know, to be able to survive, to explore, to go beyond. And to be part of that, every day. I don't care what your job is. And I hope you can walk up to anybody at KSC and ask them what they do, and they'll tell you, I launch rockets, because everybody has a role to play for us to be successful on this team. And I just think it's an awesome team and a great place to work. So the change that's happened here, the shuttle landing facility, we turned that over to the state of Florida to maintain and operate. Doesn't cost us a penny anymore, and they're going to be able to commercialize it for horizontal launch capability and suborbital missions. Blue Origin, I'm sure you all saw where they had their successful landing here a few days ago on their launch vehicle. They're coming to the Cape. They're going to be launching down on Pad 46, Cape side, but they're going to have a huge manufacturing facility on KSC property at Exploration Park. Again, another partnership with the state of Florida through Space Florida. So I'm excited about the future here at KSC. It's been a time of tremendous change, very positive change, and I feel that we have an absolutely awesome plan moving forward as we support SLS and Orion, put the ground infrastructure in place to take us to Mars one day. That's going to happen. It's real. It's not just PowerPoint slides. It's real. That we support commercial crew, have a capability to fly crews to the International Space Station on a U.S. rocket from here at the Cape, that we continue to support ISS, that our launch services program continues to provide the expendable vehicles. We got Jason 3 coming up, launch on a Falcon 9 out on the West Coast at Vandenberg, hopefully in January. This is an awesome place. We are doing amazing things every day, and it's real. It's not paper. It's not PowerPoint slides. It's real, and you can go out and see the hardware, and that, to me, is pretty darn exciting. So with that, I'm going to take any questions you got about what's going on at NASA, KSC, and where we're going.
I was curious. We actually had the opportunity to tour the Boeing facility yesterday.
Isn't that neat?
Yeah, it was super neat. It was like the coolest thing ever. But my question was going to be, with these commercial companies coming on the facility, how much of NASA is involved in what they're doing? Are you seeing the aspects that other people don't get to see? Because we were told that not many people get to see those facilities. So I was just curious how much involvement you have in those.
The commercial crew program is very involved in what Boeing's doing and what SpaceX is doing. We are active participants in helping make that happen. So we're working with them. But again, it's a commercial venture, and we have given them as much autonomy as we possibly can to operate here at KSC. But absolutely, we know what's going on. In fact, this afternoon, the Deputy Administrator, David Newman, and I are going to go out and tour SpaceX's pad and see all the latest upgrades out there. She hasn't seen it, and we want to show that off. We want to show the great progress that commercial companies are making here at the Cape.
Hi, thank you. Fred Height has a question. What do we need to learn, invent, or conceive in order to take the next big step beyond what you're currently planning today?
Well, to me, the next big step, our ultimate goal is boots on Mars. And in order to do that, I really believe that we have the right architecture that we're putting in place. It's a capability with the Space Launch System and the Orion crew vehicle. I think it's absolutely correct to turn low Earth orbit operations over to commercial companies. They can do that and utilize commercial space or low Earth orbit for commercial space. But NASA really needs to be involved in the exploration beyond our home planet. And I think the proving ground is that area beyond Earth, but not quite to Mars yet. We have to learn how to operate out there. And I think the International Space Station is just a phenomenal test bed and research facility to enable that. The systems that we have, how many, I better see all the hands go up. How many saw The Martian? All right. How many read the book before they saw the movie? How many read the book over a year ago before it was really popular? All right. I walked out of that movie and I said, man, this is so cool. I want to make that happen for real. I was watching it with our associate administrator, Kelvin Manning. He was sitting next to me. And that one scene where they're coming back from Mars and all of a sudden they zoom out in space and they show this huge spacecraft coming. I leaned over to Kelvin and I said, now that's a spacecraft. I want that gym that they had. Did you see that gym, with all that exercise equipment? That's the spacecraft I want. Now, we're not going to have that right away. All right? That's a lot of mass, and that costs a lot of money. But the truth is, we have to be able to operate out in that environment for an extended period of time. Right now, with current propulsion technology, it's 6 to 8 months to get to Mars, another 6 to 8 months there for another 6 to 8 month trip home. And the systems on the International Space Station, I bet there's not one environmental system, I know there's not, that has worked continuously without repair or replacement for a year, or two. All right, and that's what we're going to need. We're going to need highly reliable systems to take care of the crew, and as close you heard earlier, the importance of a closed-loop environmental system and reclaiming water and how important that is. We have to prove those systems, and we also have to be able to operate for an extended period of time away from Earth. When we went to the moon, that was a 2 to 3 day camping trip. If things went bad, you're always home in 2 to 3 days. All right, and like this asteroid redirect mission. When we pull an asteroid back here and put it in a lunar distant retrograde orbit, you're talking 7 to 9 days to get there in that orbit, and another 7 to 9 day trip home. That's different than we've operated in the past. The shuttle on space station, they have an emergency on space station, they just jump in their Soyuz or soon to be, CST-100 or Crew Dragon, and they're home in a few hours. All right, we need to be able to operate in that environment for an extended period of time. And I think it's developing the environmental control systems, the procedures. That's what we're going to need to focus on. And it's all stuff that we can do. We know how to do this. We just need to persevere and keep developing it. Any other questions? Mike, there you go.
Changing topics just a little bit on you, but speaking of propulsion systems, is the most likely candidate for a real change in propulsion, not Star Trek-y, but for real, plasma rockets? Is that where we're heading?
We're looking at solar electric propulsion for the asteroid redirect mission. Franklin Chang Diaz is working on his VASMIR, his plasma rocket, and that would be awesome. You get to Mars in weeks instead of months. I was talking to Franklin about it, and I said, and I understood this, but I was just talking to Franklin. I said, so Franklin, let me get this right now. You got this engine, and you have low thrust, but you continually accelerate halfway to Mars, and then you turn around and decelerate the rest of the way there. I said, so if that thing fails, you're just gone. You're not coming back. I said, what kind of redundancy do you have? And Franklin said, we'd be glad to sell you 2 of them. But, I think the future is going to be propulsion technology and what we develop, and to be able to travel these long distances faster. But our goal, it goes back to exploring and pioneering. And I've got some great slides that I use when I give talks. And one of my favorites is, I don't know how many of you read Captain Woolsey's account of Shackleton's voyage to Antarctica back in 1914, 1917. Phenomenal. This is what exploration is, all right? Explorers leave a safe environment. They go off to an extreme environment. They learn, and they to Antarctica. It got a ship locked in the ice, the Endurance, crushed from underneath them, got 2 small boats after they're living off whatever food they brought with them and whale seals and whatever, and then they take these 2 small boats to an island. He leaves most of the crew there, takes a 24-foot boat, goes to another island, climbs a mountain, crosses a glacier, goes down to this Norwegian whaling village and gets transport back to Argentina, where he gets a ship and goes back and picks up the rest of the crew, and he didn't lose a person. That's exploration. That's leadership. We need to be able to operate in an environment like that. We need to, The Martian. That story? It's a great story, but that's what we need to be able to do, to adapt and to explore. And our goal is not to just explore, to leave that safe environment, learn, and go home. Our goal is to pioneer and to actually establish a presence in the solar system beyond planet Earth. And that's where we're going. And we're making that happen today. When we go to Mars, that Space Launch System with Orion is going to roll out of High Bay 3 and the VAB on that mobile launcher that you see right now with crawler transporter out to Pad B, and we're going to Mars from that pad with that equipment. And that's pretty darn neat. Any others?
All right, last question is going to be here, and then we'll have a few more after the end of the broadcast.
So, question for you. How important, in your opinion, is international cooperation versus, for NASA, focusing more on American-made?
Yeah, I think international cooperation is absolutely important. And the International Space Station is a superb model for that. There's hardware built around the world coming together for the first time in space, and it operates perfectly. We got Japan, Canada, the United States, Russia, the International Space, the European Space Agency and all its partners, and we're working together as one team. And I think when we leave planet Earth, we're going to do it as people from planet Earth, not any one nation. And it's too expensive for one thing. We need a cooperative effort in order to actually pull it all together and make it happen. So I think international cooperation is very important to our future.
Excellent. So that marks the end of our broadcast today here. For those of you who are going to be following online and everything, we're going to be doing live coverage and picking up tomorrow at 4:30 p.m. on NASA television. You can follow along using the hashtag Cygnus. You can also follow along with Orbital ATK on their social media accounts as they go towards launch here, and ULA as they go to launch the rocket tomorrow. We're going to be doing live coverage on @NASA, and so you're welcome to join us there. Follow along and join the conversation. We'll have 2 more televised briefings today where we'll be taking your questions as well using the hashtag #AskNASA. If you want to get involved in a future NASA social, follow along @NASA Social, and we'll be sure to broadcast opportunities to come and be a part of the audience for future events just like these, where you can go behind the scenes at NASA and get that in-person experience that shows off some of the incredible and wonderful things that we're doing here at NASA to prepare for the future. Without any further ado, thank you very much for joining us. And go for launch tomorrow. Go Orbital ATK and go ULA.